AC motors. Alternating current is a type of power transmission where the voltage over time acts like a sine wave. The reason for using AC to transport power is because of power loss. When DC current is run along a wire, the heat dissipated in the wire is shown by the equation P equals I squared times R, and this needs to be minimized. One way of doing this is by making the resistance of the wire as small as possible, but that would require making the wires thicker, which would be costly. When DC is transported over long distances, lots of power is lost and the wire heats up. With alternating current, something called a transformer can be used, which can step up and step down the voltage. Two coils are wound on opposite sides of a loop that is magnetically permeable. One loop is connected to the power source and the other loop is connected to the load. By using different winding densities on these two coils, you can step up or step down the voltage. And by doing that, you inversely change the current. And when you inversely change the current, you will have less power loss if you have a lower current. So by stepping up the voltage, you can transport AC power at a lower current, which then loses less heat. AC motors work on the principle of how the strength of a magnetic field around a current carrying wire is proportional to the magnitude of the current running through that wire. The sinusoidal current that runs through an AC wire causes a constantly changing magnetic field around it. This is the principle that allows AC motors to turn. The two types of AC motors that I will be talking about are synchronous and asynchronous three-phase AC motors. Each one has two main parts, the rotor in the center that spins and the stator, which is on the outside that is stationary. For a synchronous motor, the rotor is the intersection that turns the shaft. It is usually lined with permanent magnets that get attracted to or repelled by the stator. The stator is a non-moving shell, and it has electromagnets that move the rotor. AC current is put through the coils, which in turn makes them act as bar magnets to attract and repel the motor. The phase is shifted so that the magnetic field will turn in a circle, which then attracts the rotor. Asynchronous motors work a little differently. Instead of having permanent magnets on the rotor, a conductive material is placed there. The rotating magnetic field exerts a torque on the loop, which works in the equation shown. The force is equal to the charge times the velocity across the magnetic field. As the rotor moves to align with the magnetic field, the loops and the field align, meaning the force is equal to 0 and the loop slows down. Because of this, the rotor can never move at the same speed as the magnetic field and always lags behind. But as that rotor lags behind, the cross product between those two vectors become more positive, and then it'll speed up. So because of this, it'll never move exactly at the same speed and it'll always be less. AC motors can be powered using the AC power from the wall without having to convert it to DC power. They're also low cost and high efficiency, and their speed can be controlled directly by varying the frequency of the alternating current. Thank you.